All right, let's get started. It's 4 p.m. Hello, everyone. Welcome to our MongoDB performance and security panel talk. So I know it's been a long day. Hope you enjoyed all the sessions today. And so today we're going to just talk about performance and the security. Everyone knows that both performance and security are important for a database. So we have Ken, Mark, Jer, and my name is Xiao Chen. I'm a product manager in the performance team. And so I'm new to MongoDB. I'm only here for 2 months. So today I will be mostly moderating the panel talks and probably answer some questions. And I will let Jer, Mark, and Ken to introduce themselves first. Jer, let's start from you.
Hello. Yeah. Hi. My name is Ger Hartnett. I'm the lead engineer on the performance team for MongoDB. It's a distributed team. I'm based in Ireland, but we've got people from Barcelona all the way to the west coast of the US.
Sounds good. Mark?
Hi, I'm Mark. I work on server security. I'm technical lead on client-side field-level encryption and what is the new queryable encryption project we just announced yesterday in MongoDB.
Thank you, Mark. Ken?
I'm Ken White. I'm a security principal. I focus on particularly strategic clients and sort of security critical workloads. So a lot of customers with currency exchanges, treasury platforms, settlement networks, that sort of thing. So nice to join you.
Thank you, Ken. So let's start from some of my own questions. Since I'm on the stage, I'll take the advantage. So this time, let's start from Ken. So I'm going to ask you some question about the ransomwares. Like the ransomwares, like recently in the news, like companies, they get their data encrypted and they were used to like extort payment. So what do you think, like, can you talk about how MongoDB can help people to avoid to find themselves to get into those situations?
I don't know if we're recording this, but I'll be brutally honest. So one of our approaches is that we have a very customized, hardened global infrastructure for our managed service for Atlas. We don't run Active Directory anywhere. We don't run Windows anywhere. The individual underlying VMs for the clusters and in some cases containers, these are very hardened, very specific images. So these aren't like sort of generic, Red Hat or that sort of thing. These are minimal installs with minimal listening services. And then by default, we've got TLS enabled. There's no ingress allowed from the network side. We've got really strong boundaries that limit any potential movement between customers. Now, federated identity, all sort of the standard things that are now increasingly kind of table stakes. But all that said, if you go into Atlas or a self-managed database and you say, drop the firewall, I'm going to change the default configuration, I'm going to listen to the world, I'm not going to turn on authentication, you're going to have a bad time. But you're going to have a bad time whether it was us or any other database. So there's, in the Atlas world, at least you're going to get pinged with an email every single day going, hey, by the way, in addition to the red flashing thing on the console, this is not a good idea. Are you sure you know what you're doing? That said, there are really well-organized criminal groups that's their thing. They do ransomware, and these organizations have 24/7 customer service. They literally will help you set up a Bitcoin account and get them paid. So I think I think it's a concern and it's a threat for sort of across the industry. But I think we've done a pretty good job in terms of the defaults and sort of how we look at that from the first place. But it's definitely a shared responsibility, and a lot of these are just sort of security 101 foundation principles.
Thank you, Ken. So you mentioned Atlas. So I have a question for you, Mark, about Atlas. So can you tell us like how Atlas can help us to make security easier compared to like self-deployment MongoDB, including like on-premise ones and also the self-deployment in cloud?
So the biggest advantage of Atlas is that you basically have an expert pool of MongoDB developers, developing and running Atlas. So, we we, by default, turn on authentication. We turn on TLS 1.2. We don't even allow TLS 1.1, which is ancient and has some weaknesses. We also have give the users the ability to firewall to allow to allow connections from only trusted hosts. We also will, I think we do password checks now. We also have the Scram SHA-1 on by default. We allow users to configure their own LDAP. Finally, we also have bring your own key, so that and client-side field level encryption, and soon to be becoming queryable encryption. So this allows you, with bring your own key, you will have control over the encrypted data. So the Atlas database will be encrypted on disk. You control whether Atlas administrators even allowed access to it by, you control the AWS KMS keys yourself. Let's see. And then client-side field level encryption prevents, like, if you're actually even worried about, you trust this with your data, but not to see certain sensitive data, you can encrypt it such that only the client can decrypt it, and the server can never see it. So that is an advanced level feature that we can, set up and configure for you. And one of the advantages of Atlas over even on-prem is that we support AWS KMS for bring your own key. On-premise, we only support KMIP. But in Atlas, we support AWS, Azure, and GCP. And then we also have again, this is also run by an expert set of MongoDB developers. So we don't, if for some reason there was a vulnerability to come out, we can protect it and safeguard it faster than you can. And we will also, by the time the CVE comes out, we will patch the fleet. Like, we get these notifications internally, we process them, and we're always a step ahead in CVE notification than an outside vendor. And this is true, this is not just specific to us, this is true for most vendors. By the time they actually tell you about the vulnerability, they've patched their on-premise, their cloud deployments.
Yeah, let me add some color to that, because I think people in the room are probably aware of Atlas, but you may not be aware of the scale. So we're operating over 2.5 million databases worldwide right now. We run in over 200 data centers in all the big three public cloud providers. So when Mark talks about patching and updates and scaling and keeping up with these security, we're doing that on a massive scale, and there's not a lot of human interaction. It's we have 24/7 scanners that are looking for vulnerabilities that have been published. We spend thousands of machine learning hours with dynamic and static code analysis and with path analysis. So there's a ton of things that happen before it ever makes it, the images ever make it to the public. But that said, I mean, we're not, we'll never make any kind of grandiose promises about, hacker-proof or things like that, but we try to continually kind of evolve our security posture. And so, yeah, part of that involves patching and updates, and then doing the necessary regression testing. For any individual, driver, for example, we have thousands and thousands of regression tests that we do sort of, burn testing to make sure that before we roll out one of those minor kind of like surgical, laser-specific code patches for a security bug, we've already tested it extensively. So that's just really, you can do it, when you manage your own platforms, but it's really hard. It's hard to keep that up where you can't take a break. You can't look away for a few days, in an internet-facing context.
And one last mention, finally, the best thing you can often do with software is stay up to date. So we as MongoDB will stay up to date with MongoDB. Also, we are following the industry best practices for keeping up to date with like NPM packages and Java packages. So we have continuously patched the fleet and roll out new versions of Atlas almost on like a daily basis. And track CVEs in various things, and just continuously keep that software up to date, so that there's no like, oh, we deployed that, we left that, a year ago, because we're scanning our own software for vulnerabilities, and we work with 2 different outside companies, depending on the language, to keep track of, when they release the newest third-party dependencies.
Sounds good. Thank you, Ken and Mark. Very informational and very good advice. And so now I have a question for Jer about performance. So when we are doing performance troubleshooting, so how do I know the database is becoming the bottleneck instead of like the other part of my applications or my services?
Yeah, I guess when we work with customers or partners, that kind of becomes the first question. In any performance tuning exercise, there's at a high level, there's probably 20 different places that can be the limiting factor or the bottleneck in an overall system. A system is, interacting elements, and it's kind of like I think Asia and Joanna were talking about it earlier. It's kind of like a Sherlock Holmes novel. You're trying to kind of do detective work to figure out where the current limiting factor is. One of the simple ways is, usually in all of those components, it can be either I/O bound or CPU bound. So, one thing you can do is vary either of those. If you think the bottleneck is a database, increase the amount of CPUs you have or the CPU frequency, or increase the I/O and see if performance improves. And if it doesn't, the performance problem is somewhere else. So often it's a case of, doing the process of elimination, have a hypothesis and validate it.
Thank you, Jer. Very good answers. And you guys see I have a very long list of questions from myself, but we've been told that we need to be nice to our guests. So I'm going to give you guys opportunity to ask your questions before I ask mine. So, okay, just raise your hand. I'm going to hand over your mic. So you're the first, you're the next, you'll be the third one.
Okay, this is about performance and indexing. Let's say I have an actor document in my collection with actor ID as primary key, a unique number. Then I have movie document within the same collection. And I have actor ID field, same name, but instead of a single value, it's an array with elements referencing to actors who played in that movie. So if I create index on actor ID, will I be able to get, when I query the collection where actor ID is given value, will I be able to get the actor document in addition to the movies that he or she played? Or just the actor document?
Sorry, I'm finding it very hard to follow. I think we probably need to chat afterwards, and maybe we could write it down. Okay. And it's one of those questions. It's easier to kind of see it on a piece of paper. Yeah, maybe we'll chat about it afterwards.
Yeah, I can write down the schema.
That would be good if you could write it down. We'll chat after. I'm sorry, I just couldn't follow. I'm trying to visualize it in my head.
I think I kind of get the question.
Okay, so, go for it.
Yeah. So I think the question is that if you create the index on actor ID and when you query the collection, can you get other fields in your query? Is that correct?
One document has single value. The other document has an array, but the field names are same. So one is single value.
Yes.
Is an array.
Yes.
Same name, and each element within the array is pointing to different actors.
Yes.
If I query collection where actor ID is 1, 2, 3, will I return all the movie document that person played in addition to the array?
Yes, it doesn't matter if that's a single value or array. If you query, for example, Johnny Depp, you will find other movies he played by himself, and also he played together with other people.
Yeah, but those kinds of indexes where it could be a single value or an array, there's some performance complexities with those. So there's some very detailed documentation to read about that. We can talk about it afterwards offline, but it gets complicated.
Okay, who was the second? I think I'll come back to you.
Yeah, I just have a fundamental question about, we talked about Atlas security and, all those good stuff which you talked about. What is the plan for the on-prem, software which people have? Are they going to remain vulnerable, or is there anything MongoDB is planning to kind of make those, softwares also secure and up to date with how the Atlas is progressing?
Well, for us, like honestly, sometimes in server, we think of Atlas and on-premise the same. So there is nothing special that we're doing just for the most part, just for Atlas. We do the same sort of third-party updating for whether it's the server, Ops Manager, Cloud Manager. We keep the software up to date. Now, whether a customer updates to the latest version is still on them. But we also have best practice in terms of one of the big changes we made. I think it was 4.0 was we now local host only by default. We still auth is still off by default, but by default it comes out of the box that you're no longer able to connect from a remote machine, which increases the default safety policy, but it's still on you. But Ops Manager and Cloud Manager can help that by notifying you when when MongoDB is out of date.
So is that like the same way, like you said, like every 2 week, 1 week, you're releasing the different versions for Atlas? There's the same frequency for the on-premise?
For the you have to update the software.
Yeah.
Like Atlas deploys almost, I think, on a daily basis, or I don't know the exact frequency. But yeah, you'll have to update the MongoDB versions. We normally release if on like a regular cadence, but if there is a CVE, there's an actual security sort of threat, we will make sort of a quick release and notify customers that it is an issue. If it's actually exploitable, that's a bigger deal versus something that you can't actually won't impact a customer.
Yeah, we should also mention that the Atlas fleet, the huge fleet that we run, at its core is enterprise advanced. So it's not like there's a separate project over here that's kind of gathering cobwebs or whatever. That's absolutely the core of our offering. So yeah, as Mark said, when there's a security critical bug, we'll get that, whether it's in the driver space, it's in shell, it's in one of the tools, it's in the core thing. We'll patch that and make it immediately available. It's obviously a little easier if you're on Atlas, but no, those CV channels you can subscribe to and get sort of real-time notifications when they break.
Yeah, the enterprise binary and the Atlas binary are the same.
Thank you, Ken and Mark. So, okay, next question.
Thank you. Performance. All right, you're troubleshooting a performance problem. You go and look at the metrics. What key metrics do you look at first? Are tickets one of them? And how important do you regard tickets in troubleshooting?
You mean the WiredTiger tickets?
Yeah.
Yeah. So it depends on the problem, really, as with all of these things. So is everyone here familiar with the WiredTiger tickets? Some people are. So they're basically a set of semaphores between the WiredTiger storage engine and the main part of the database. And it's basically how the concurrency is controlled. So, if you have more, and they default to 128 each. So if you want to increase the amount of concurrency that's basically running inside the database, you can increase or reduce those. Some customers will actually use it as a way to try to, let's say if you wanted to prioritize reads and limit the impact of writes on reads. So there was a particular customer who wanted that at one stage. They cared more about the read latency than the writes. The writes weren't as important, so they were okay with bursts of writes, not running as quickly as possible. So they actually tuned down the number of write tickets. So you can do tricks with them, but that's not really what they were there for. So ultimately, if you find that, what I've seen some customers will do is they'll kind of change those numbers based on the number of cores they have. And then it'll depend on the number of, real cores versus hyper-threaded cores and stuff like that. So it's kind of an experimentation thing. But, that you're getting into serious weeds there. I'd start elsewhere, I'd start looking at queries, looking at the CPU utilization, whether it's IOPS or the limiting factor first. Sometimes to a person with a hammer, everything looks like a nail, so, and yeah, it really depends on the problem. That's what I love about performance is there's so many different places where the problem could be. It really is, you know, like a detective story, and you're trying to kind of narrow it down. So I think the answer is it depends.
Like sometimes you want to maximize CPU usage. Other time, like you may look at it. Oh, look, I'm maximizing CPU usage. Maybe I need a bigger CPU, so that's why I'll increase it. Or I'm maximizing CPU usage, and you know I can lower. Let's see, you can, yeah, bigger CPU there. You know the IOPS are running slowly. Like your drive is running. You know, in the old days with spinning Rust, it was like, oh, it's running over 100 milliseconds or something. Then it's a sign that I need faster I/O in order to catch the database up. These are the simple metrics. Like if the CPU is low, maybe it's stuck doing I/O, and I actually need more I/O to actually carry the CPU usage up. You know, the right tickets. If the right tickets are exhausted, maybe it's because you don't have enough I/O, or you're basically overwhelming the system. Because there is, if you throw 1 million connections at the system will not handle it. This is sort of the reason why we actually introduced the tickets. It was like, okay, we can't have 1 million threads sitting in Wired Tiger. What was the magic number? And to Jer's point, it was sometimes like, okay, my goal is to try to do more requests in the server. Sometimes it's like, I have to experiment, lower this number. Well, did my performance overall requests go down per second or per minute or up? Well, it didn't go the way I wanted. If it didn't go the way I wanted, I have to change, run a different experiment.
Yeah, but if you have too much parallelism, then you're spending more time context switching, you know, so it's lots of trade-offs, and it depends on what you want to optimize, you know, and it comes down to throughput, latency, those kind of trade-offs.
Yeah, like you can increase CPU usage and actually have lower performance because it's doing less good work.
Yeah.
Okay, I just asked because we've left tickets at the default. We never tried to tweak that, but I saw in another presentation, like there was an alert if there are fewer than 10 tickets remaining. I want to know if there are fewer than 90% of tickets remaining. That's what we've found. Like if it starts to drop noticeably, we're headed into trouble. So I don't know, maybe that's specific to our workload.
Yeah, it could be. I mean, the thing is, if a system is overloaded, you need to rate limit it somewhere, right? And there's so many places you can do that, and I think that's kind of too late. If you're using that mechanism, that's not what it was really meant for. And as Mark said, if you've got too many, you're spending more time doing, not actually running the workload. It's context switching. It's managing things. So yeah, I don't think that's the place to start.
Thank you. Any other questions? Okay, ladies first. I'll go back to you.
Maybe it's a quick answer. It's about vulnerability scan. If you find a weakness, how long does it take until you're patching Atlas? And if the weakness is solved with a higher version, are you forcing then an upgrade on Atlas? Or can I stay on my current version?
No, that's a great question. So we're running automated scans 24/7. So we sort of try to hack ourselves, constantly. We've got in-house, red teams that are doing that as well. If we see something, we'll assess it, we'll triage it, we'll try to understand what's happening, and then when a patch is available, anything that's still in, current LT, long-term support, we'll absolutely patch. We do have some institutional clients that you can imagine if you build the tech like really deep into an infrastructure stack that's processing billions of dollars per day, that's not something you can trivially pull out and update. And so in a few cases we have, got extended, support agreements in that case. But no, I don't think you're ever going to have to force an upgrade in Atlas to like a major, version level. But we will absolutely it's based on the severity. If something is remotely exploitable, then yes, we're going to downgrade, one at a time each of your nodes. We're going to do that sort of patch in place, and we're going to push it back. There are maintenance windows that you can use for backups, but we don't I'm not sure if that applies for security critical bugs. For sort of standard, routine kind of, like CV5s and lower, those are a much slower cadence. But no, we're never going to make you sort of forced to upgrade because of a security patch.
Hey, this is an open-ended question. What are some of the best practices for developing read and write heavy systems? I mean, there are systems that, for example, a trading system where you push a lot of data as well as you read a lot of data. What are some of the guidelines that you can tell us?
So read and write at the same time. You want to optimize both, basically.
Yes.
Yeah.
And it has to be consistent, highly consistent data.
So you want everything.
Of course.
You want it all. Well, I'll put in a quick plug. We're actually doing, Zhao Chen and I are doing a workshop tomorrow where we go through, we've got like 12 patterns for scalability and performance. It's tomorrow.
11:15 at room 410 and 412.
Yeah, so sign up for that. We'll go into huge detail there. I think, yeah, it's usually there's a lot of kind of decisions you need to make, and if you care about one or the other, there's definite strategies for favoring writes and reads, even in the way you configure sharding. So it's almost easier if you know you want to optimize one or other of read or write. So that's a tricky one. It really comes down to experimentation, and we used the example earlier where you might actually, at the moment there aren't a lot of controls in MongoDB for that kind of workload isolation. There's tricks like if you can use analytics nodes and send secondary reads to those to take some of the read traffic off. You take them out of your replica set, you make them hidden secondaries. So there's ways you can offload it. But I think that's an area of the product, in the longer term, we're looking at improving to give you finer grained controls for those kinds of trade-offs.
I would second that. The analytics nodes will avoid the collection scans on your main primary, and that will probably be the biggest detriment to predictable performance, because those will pull in too many pages into WireTiger.
And it'll basically kill your cache.
Yeah, another thing I want to mention here is that you can also do materialize some of your views, just like you use $out to save some of pre-materialized views into another collection, so you can run query on top of that instead of every time you have to do the aggregation in real time. And we had a talk yesterday about that, so I believe next week all the recording will be available. If you're interested, you can look at that talk as well.
Thomas Roitsky,
right.
I think, did that talk.
Yes, so if you want to read fresh data, that's not going to work for you. But if you want to do some analytical workload, that's the way to help you to get better read performance without impacting your write performance. Any other questions? We got 2 minutes left. Okay, if not, I have one last question. So there's a reason we put performance and security together, because sometimes performance and security can be the opposites. You have to sacrifice performance to get better security, and sometimes have to sacrifice security to get better performance. So I want to hear from each of you. Maybe keep it short, maybe 30 seconds. What do you think? How can we find a good balance between performance and security? Let's start from Jer.
Well, I guess the highest priority is security, and then you work out the performance afterwards. It's one of the non-negotiable things, really.
Most of the cryptography and whatnot SHA and hashing algorithms are accelerated in the CPUs today. The slowdown isn't like the old days, so TLS is free. So there's no reason not to have authentication in TLS. They get out of the way once the connection is established. just use them?
Yeah, we do get asked from time to time, if there's specific AMD or Intel processors that you should choose, or I guess even on AWS, the Graviton processors. And we say yes, anything with AES-NI, which is basically anything since 2010. So it's the hardware accelerated crypto is pretty much a solved problem. But yeah, these tensions always exist, and it's part of engineering, right?
With your application, though, if you are using TLS and you're opening and closing a lot of connections, if you're not doing a lot of operations per connection, or you haven't set up your connection pools correctly, you can be wasting a lot of CPU cycles going through those handshakes.
Yeah, actually, if anyone is interested or uses client-side field level encryption, I'll give you a quick tip. Do not run Mongo Crypt D in spawn mode. What that means is that whether you're Java or Python or Node, the default is to spawn the daemon on demand, and then it runs for like a minute or so, and then it self-destructs. It's better to run that in startup, like when the entire VM starts. You're going to get hundreds of milliseconds performance better. But even better than all that is just don't use Mongo Crypt D and use the new shared library that we've introduced. So that strictly uses semaphores and memory pipelines. So should see some performance benefits, and it's operationally just much easier to use.
Thank you, Ken, Mark, and Jer for the panel talk, and thank everyone here for coming to the talk, and hope you enjoy the rest of the event.